All right, this video is going to be a reminder for us of how to solve equations using factoring, only we're going to solve larger polynomials. You may have factored with quadratics before, but larger polynomials will just have more answers. So the first thing we are going to look at, though, is a quick review of quadratic factoring. These two problems here, although they aren't quadratic, are actually very reminiscent of quadratics. If we think about it, x to the fourth minus 81 looks a lot like x squared minus 81. And if that were the case, that's a difference of perfect squares. So I could factor that into x minus 9, x plus 9 equal to 0, where x times x is x squared, negative 9 times positive 9 was negative 81. And remember that your outside and inside terms, negative 9x and positive 9x, added together and disappeared. That's why we don't have a middle term, such as over here on the right where they have that 3x squared. Right now, we don't have those parts. Now, in order to kind of compensate for the fact that this is actually x to the fourth, one really nice thing is you can get away saying that these are actually x squareds in your factors. So that now we can say, well, if that's x squared times x squared is still x to the fourth. And again, the outside and inside terms are just opposites and cancel. But now I got two things multiplied equal to 0. So using my zero product property, I can split that up. I don't need that parentheses, so I'm going to get rid of that real quick. I can split those up, though, and make that x squared minus 9 could have been equal to 0, or x squared plus 9 could have been equal to 0. I can factor again over here at the left if I'd like to, or I can just solve. Remember, that's a fairly simple quadratic, where x squared would equal 9, and therefore if I took a square root on both sides, and don't forget to say plus or minus, but x would be equal to plus or minus 3. Or if I subtract my 9 over here to the right again, I get a negative 9. And now when I take my square root, you'll notice I get a negative number. Well, negative under a root is a imaginary number. So again, I'm going to get plus or minus, because I did not forget to take plus or minus. The square root of 9 is 3, but the square root of a negative number, remember, would have had an I in front. You won't always have to find those imaginaries, but it never hurts, as long as you know how to find them. Just find them smoothly. Now, over here at the right, you'll notice again, we've got that x to the fourth. So again, if I kind of imagine that's a 2, and where we have x squared, we could think of that as a 1, we can just factor this as though it were quadratic. So take a second to think about how would I come up with my quadratic factors. Remember, I'm going to look for what multiplies to the end and adds to the middle. So what multiplies to 2 but adds to 3, and in that case I would say 2 and 1 happen pretty well. Both being positive should work out just fine. And again, if I go back to thinking, okay, wait a minute, I'm supposed to be x to the fourth, can't I just say x squared times x squared? And now my outside terms become 1x squared, my inside is 2x squared, and 2x squared plus 1x squared is a 3x squared. Again, split those two things up. X squared plus 2 could equal 0. X squared plus 1 could equal 0. So x squared could equal negative 2 or negative 1, and thus x could equal plus or minus I root 2, since it's not a nice square root, or just square root of negative 1 is just I, and don't forget your plus or minus. So again, we're just going to get more answers because we have more parts. Now, what if things aren't quadratic or don't look like our old factoring terms? Well, there is a formula called the difference of squares. There's also a formula called the difference of sums. And the difference of sums, or difference of cubes, I should say, not difference of sums, the sum and difference of cubes formulas look like this. If you have two perfect cubes, two numbers that are x to the third, or you could imagine that 1,000 is really the same thing as 10 to the third. Over here on the right, we also have x to the third plus 27, remember, is 3 to the third. So if you have two things that are perfect cubes, we could hopefully use these sum and difference cubes formulas. Notice that if we're a difference, like over here at the left, we're going to take that first term and call it a minus b, or basically for us, x minus 10, what our bases are in that front set of parentheses. Then the second set of parentheses looks a lot like a perfect square, only you'll notice in the middle there's no extra 2. Normally that's a 2ab. Right now that's not the case. When you work out this sum and difference of cubes, that wouldn't be a good thing. So we are going to square our first term though. Then we're going to take x times 10, so we'll just call it 10x. But notice that this is a minus, even though this was a minus. Over here we have a plus in front of that ab term, so this is going to be a positive here. And then finally we've got plus 10 squared, or 100. Let's do the same thing over here at the right. Notice that with the sum of cubes, we're going to be a sum in that first set, so it's going to be x plus 3. Then we're going to take that x squared. Notice this time it's a minus, so there's where the big change in the formulas come. If you started with a minus in front, this is a plus. If you started with a plus in the front, this next term is a minus. But I'm still going to say 3 times x plus 3 squared, or 9, and we're still equal to 0. Now we have a way to solve. So let's go ahead and split them up. Either x minus 10 could have been 0, or x squared plus 10x plus 100 could have equaled 0. Same thing on this side. X plus 3 could equal 0, or x squared minus 3x plus 9 could equal 0. And finally solve. X could equal positive 10, or, and since this is quadratic, I think our best way to go about this is probably just going to be to go ahead and use polyroots. So I'm going to go ahead and head into polyroots here and say menu, remember 3, 3, 1, and I have a quadratic. I'm looking for possibly complex numbers, so I'm going to go ahead and put complex in there. And then I need my 3 numbers, which for us on the left side here were a 1, a 10, and a 100. So 1, tab to the next box, 10, tab, 100. And when you press enter, hit OK, it's going to type that in for you. And again, hit enter one more time, and you've got your answers. Notice -5 plus or minus 8.660i. So -5 plus or minus 8.660i. Again, if you're looking for complex numbers, that's great. If they only say find the real values of x, then we could have stopped at the 10. That's the only real one you're going to get. Go ahead and do polyroots for the one on the right side here. Obviously, we can solve the first part fairly easily, but we're going to need polyroots again on that next part. Now, a nice thing is I can just go up, since I know it's quadratic, and I could copy that. And since I know I just need to change my middle term to a -3 and my last term to 9, I don't have to redo the entire thing. But now I get 3 halves, or 1.5, plus or minus 2.598. So 1.5 plus or minus 2.598i, and I've got my answers there. Get to know those sum and difference of cubes formulas. They are advantageous, and you will use them a lot in your homework, so make sure you copy those down. Next, one more great way to solve a polynomial, if it works, is called factoring by grouping, or grouping our terms. If you have 4 parts and it's a cubic, grouping doesn't always work, but you can at least try it. And what that means is I'm going to group my first 2 terms and my last 2 terms. Kind of like how we solved quadratics when you had a leading coefficient that wasn't a 1. There was a solve by grouping method. So we're going to do that same thing. What's in the first 2 parts? So I'm going to take out a 10x squared, since that's the most that I can get, leaving behind, if I divide out a 10, there's a 1 left, and if I divide out x squared, it's just an x. Plus, divide by 10 is 2, and you took out the x squared. Plus, notice there isn't anything in common for x plus 2, so I'm going to take out a 1, and then I'm just going to say x plus 2 over here at the right. You'll now notice that x plus 2 and x plus 2 are in both terms. So again, I'm going to think about it, that big factoring separated by this plus sign in the middle. If there's an x plus 2 in both parts, I'm going to pull that out in front. And if that's removed, then you're left with 10x squared plus 1. So we're just going to say 10x squared plus 1 right there, which now gives us a way to separate our two parts since they're multiplied equal to 0. And now we can solve. So I would subtract 2. X equals negative 2 is one of my solutions. And if I subtract 1 and divide by 10, then take the square root, you'll notice that we again get imaginary numbers, but the square root of 1/10 being square root of 1 over square root of 10. So I'm going to multiply the top and bottom by root 10 to get that root off the bottom. Doing a little side work here, I've got root 10 over 10, or plus or minus root 10 over 10i. And we've got our answers. Go ahead, there's two examples here on this next page. See if you can solve those. I'll fill them in here in just a minute, so go ahead and pause the video now. Try them out. Good luck. All right, here are both answers worked out for you. So on the left side here, I noticed right away that there was a 3 in both parts, so I went and pulled that out. Then I noticed that 1, 5, and negative 24 would factor using a nice plus 8 and minus 3. Don't forget you need x squareds to make that x to the 4th, and the 5x squared in the middle. But now I can split into all three parts. Realize that 3 equals 0, since again it's multiplied by these other parts equal to 0. 3 equals 0 though doesn't have any solutions, of course, because 3 can't equal 0, so you just kind of ignore that part. Solving the x squared plus 8 in the middle, you're going to end up with plus or minus I root 8. Don't forget to break down that 8, 2 times 4, and the square root of 4 being 2, so I can pull that out in front. So I get plus or minus 2I root 2. And on the right side here, I've got a 3. So I took the square root, said plus or minus root 3. You could also find those decimals, but again, nice exact value answers are always good. On the right side here, first of all, factoring is only helpful when you're equal to 0, so don't forget to move that 2 to the other side. Then I grouped my parts. Notice there were negatives in the second part, so I left the negative inside the parentheses. Always a good idea, so that then I can factor out that negative 1, leaving x squared minus 1 on the outside and x plus 2 on the inside. So those are my two different factors. Sorry, I kind of skipped a step there. You've got your x squared minus 1 times your x plus 2 all equal to 0. So again, I split to the two parts, solved those out, and got plus or minus 1, as the square root of 1 is just plus or minus 1, and negative 2 for answers. Hope that helps you solve by factoring. Good luck, and have a great day.